Now I'd like to look a little bit more at the core programming languages that you're going to learn in this course. The first of which is Python. So I think most of you have already started doing some Python. You started learning it. But I want to talk about it on a more background level. So Python is a general purpose, third generation interpreted programming language. So this is in the computer science classification of types of programming languages. This is how it's classified. General purpose means that Python is used for all kinds of programming scenarios. Here we're going to focus on using it for machine learning and for data science. But Python was, I think, primarily developed for web programming. Python is used for app programming. It's less used for compiled programs, but it's designed for programming all kinds of systems, many different kinds of systems. And that's not the case for all programming languages. A lot of programming languages are designed to focus on a very specific kind of context, like JavaScript and Java were designed for web programming. Java was designed for server-side programming, JavaScript for client-side, and some programming languages are for app programming, but Python was designed to be used for many different kinds. Okay. Then it is a third generation programming language. To briefly summarize what that means, so we've all heard that computers really work on zeros and ones, right? So first generation computer programming, literally, computer scientists programmed in zeros and ones. 0, 0, 1, 1, 0, 0, 0, 1, 1, 0, 0, 0, and that tells the computer what to do. So the computer scientists had to learn the literal 0 and 1 language of the computer in order to tell the computer what to do. And they actually use punch cards. They have cards that they make some holes. A hole is a 0, then there's no hole, that's a 1. And they fed those cards into computers to tell computers what to do. That's called the first generation of programming language. Then after that drove some computer scientists crazy, they made things simpler. They used small, simple English words, such as add 2, then space 3. And then so those are 3 words. Add, ADD, space, 2, space 3. And that tells the computer, give me 2 plus 3, and the computer gives it 5. So add 2 to 3. And so that way, where you actually use numbers, like decimal numbers, and you have short little codes, like multiply might be MTP 2, 3, so that says give me 6. That's called second generation programming, where at least programmers are not programming in 2s and 3s, but actually the way it works is that the computer takes the ADD and translates it into 0, 1, 1, 1, 1, 0, 0, that it understands. Then the 2, it translates into 0, 1, 0, which is 2 in binary. The 3 translates to 0, 1, 1 in binary. So it directly takes the human words and converts it directly to zeros and ones that it can understand, and then it does the 0 and 1 operation. So that is called second generation programming. Third generation programming is where instead of words and numbers that map directly to zeros and ones, the programmers think more in terms of the steps they want to do. They assign things to variables. They have functions that go to code here and there. So the kind of thing that most of you have been already exposed to in Python, for example, that way of programming is called a third generation programming language. There's a fourth generation. I'll talk about that shortly. But Python is on that level. So it's and the significance of a third generation programming language that is considered today that is the lowest level that programmers work on usually. So the most advanced kind of programmers that top computer scientists work with, they don't go down to first generation or second generation. They work on third generation, meaning it can do just about anything a computer scientist wants to do. So it's a very flexible, very powerful kind of programming language. So that's the meaning of that. Interpreted. Interpreted means, okay, the traditional way of creating computer programs is called compilation, or a compiled language. So you might have a computer program, and the computer reads that program and converts the entire program into zeros and ones, and then runs the program. And that is how most computer programs are run. It's pretty fast, because the computer can only work in zeros and ones. It has to do some translation, but the point of a compiled language, it converts the entire program into zeros and ones, and it runs the entire program. But an interpreted language, the computer reads one line and converts that line to zeros and ones and runs that one line. Then it goes to the next line, converts it to zeros and ones, and then runs that next line, and so on. And that is a lot slower for the computer, but it's a lot easier for the programmer. Because if you have a program of 1,000 words, and you made a typo in one place, or an error, and you go and fix it, in order to run it again, the computer has to recompile all 1,000 lines, and then run it, and then you discover, oh, there's still an error. You go back, you find the error, you fix it, the computer has to compile all 1,000 lines to run it. Oh, there's another error. So each time the computer has to redo it. So it's much more cumbersome in the process of writing a program. But an interpreted program, you fix one line, the computer only reruns that line, everything else is fine. So it's, I'm just trying to give you the idea that it's much easier to work with. So something like when you work in data camp and you enter this line of code, oh, there's a problem here, you can't do that so easily if the computer has to run everything every time. It's because it's line by line. It's just much easier to work with. Programmers enjoy working with that kind of program much more. And that's the nature of Python. So it's general purpose, can be used for programming almost any kind of thing you want to program. It's third generation, very flexible, very powerful. It's interpreted, so very easy to work. Okay. Now, Python was created by Guido van Rossum. He's a computer scientist, first published in 1991. It was, its primary selling point is that it's just such a well-designed, clean, consistent programming language. So for computer programmers who have learned many languages, there's some inconsistencies. Why do they do it this way, that way, and that way, that other way? The way the language is done, you can easily make bugs and you don't find them. But Python was so carefully thought out that it's easy to learn, easy to program with, consistent. It's really a beautiful programming language. And that's why, that's one of the primary reasons it has become so popular. It was named after, not the snake actually, but a British comedy troupe called Monty Python's Flying Circus. So I guess Guido van Rossum, who is Dutch, but I think he liked that comedy troupe, so he named the programming language after it. Now, when it comes to statistical programming or data science, which is a little bit different from artificial intelligence and machine learning, this is one of the, so as I said, Python was created for all kinds of computer programming. But when it's created for all kinds, that means that if you have a very specialized use, it's not necessarily the best. So it was not created with statistics and data science in mind. And data science mainly has to do with storing data, with organized data, and working with changing, manipulating, plotting data. Python was not designed with that. So raw or basic Python is not particularly good for that. But because of how important these parts are, some libraries or extensions have been built for Python that are very well developed now. So I think you've already seen these. NumPy was created arrays and matrices that can be used to store data. Pandas, data frame, to store a table of data, because Python doesn't natively have the idea of a table of data. And matplotlib was designed for plotting graphs. So these are extensions of Python that let it be usable for data science. Any questions so far? Okay. Now these concepts, arrays and matrices, data frames, and graph plotting, actually were copied pretty much directly from another language, which is very good at these things, and that's R. Okay. So R is a third generation interpreted language for statistical programming. Third generation, again, it's written in a way that it can do anything the programmer wants to tell it to do. They can tell the computer to do it step by step. Interpreted, it's executed line by line without having to compile an entire program at a time. So it's very easy to work with interactively. But R is not a general purpose programming language. It's not built for all kinds of computer programming. So for instance, you cannot use R to design websites. You cannot use R for building apps. It doesn't have the features for that. But R was designed for statistical programming. It was built for doing statistics and data analysis. That is what it was built for. And it was created by two statisticians named Rossi Haka and Robert Gentleman. It's first published in 1995, so about the same age as Python. If Python is a beautiful programming language, I like to think of R as a dirty programming language. But dirty in the sense of, think of a cute kid who plays in the mud and climbs trees. Okay, it's not well behaved, but he's cute. And he's pretty capable, he can do a lot of things. That's what I think of as R. R was designed for statisticians, by statisticians, for statisticians. They were not computer scientists, so they were not very good at consistent ways of designing. R does one thing one way and something similar in a very different way. It was based on an earlier statistical programming language called S. It's called S for statistics. And so they named it R because R comes after S in the alphabet. And their first names happen to start with R, so that's a good name for a programming language. That's how the name of it. That's why it's called R. Okay. Now, some unique features that R has that are for statistical programming. So I've learned many programming languages over the years, and it took me a while to understand the R way of thinking. But when I finally understood it, it just really blows my mind. Some of the features R has that I've not found in any other programming language. Some outstanding things are one, vector programming. So if you know something about some programming languages, like a simple variable is like maybe you have an integer that's a single number. R does not have simple variables. The smallest units that you can work with in R is, you can think of it as an array. An array of variables. That's the smallest unit. If you want to work with a single variable, then it's an array of length 1, but it's still an array. And that's a very hard idea to work with, but what it turns out to is that when you work with R, arrays, you can do things like 50 times faster in native R arrays than if you do it one by one, thinking in terms of individual variables. It's a little bit of an advanced concept, but it's a unique feature of R. Then the idea of the data frame, that is a data object that is a table, that's an R original idea. The idea of table is not original, but building it natively into a programming language. As I said, Python did not have that. They had to have extensions to copy what R did, but R has it natively, and being native means that it works so smoothly in the language. So if you're dealing with data manipulation, R is designed for that. That said, there is a very, very important extension to R, which you'll encounter the name, but it's called the Tidyverse, the R Tidyverse. So as I said, R is a dirty but cheap programming language designed by statisticians. It didn't just start in 1995. It's based on an earlier programming language, S, that was designed by statisticians since 1976. And it just has a lot of gunk, a lot of bad designs, and R just repeats them, a lot of inconsistencies. The negative side of it is that it's just very inconsistent. You do things one way, another package does things another way. The positive side is that there are thousands of packages. I think R has far more packages than Python that can do almost anything you want. Anything you want to do, someone has probably built a package that you don't have to program it. You just install the package and it can do it right out of the box. So that's a positive side, but each one does things in a different way. So, RStudio is a company that builds software for R, and its chief scientist, the computer scientist called Hadley Wickham. They have, over the years, built a mission to clean R up, and the Tidyverse is a design philosophy of a way of designing our programs so that it becomes consistent, clean, and beautiful. And a lot of our packages conform to the Tidyverse philosophy. And they're designed in a consistent way so that you know how things work. They work very well with each other. You do things in one way with one package, it works the same way with another package. And this is called the Tidyverse. So some notable features are they improve the idea of the data frame, the table, so that it works much more beautifully, smoothly. One of the primary packages of the Tidyverse is called dplyr, which is used to manipulate data. So if you're doing any analysis that needs you to read in data as tables and change the format, transform it, I've not found anything so powerful, so flexible, that makes things so easy as dplyr in sorting the data, twisting the data, pivoting the data. It makes things so simple to do complex manipulations. One of the trademarks of the Tidyverse is called the pipe. And again, how do I describe this? When you're in computer programming, when you have one function after another, usually you put one function inside another function, inside another function, inside another function, and it gets very hard to follow, so people say don't do that any longer. But the pipe in the Tidyverse says instead of that, you do one function, then it feeds to the next function, and feeds to the next function, and so you can string functions one after another, and it's very clear, step by step. And it's the only programming language I've ever seen that has that feature that makes it so simple to have function after function in a very clean way. Then another outstanding feature of Tidyverse is ggplot2, which is for plotting data. And it has flexibility. You can plot almost any kind of data visualization you can imagine. I will say that there's a Python clone of ggplot2, which is called, I think, plot9, which basically clones its functionality, but it's hard to keep up because ggplot2 keeps getting better. But the point is that with the Tidyverse, R has become a very clean, capable programming language. So I'm spending time introducing these because these are the two primary programming languages you're going to learn this semester. This month of September and I think the first half of October, you're going to focus on Python. And then from the middle of October through November, then you'll be introduced to R. And this is just some background to these languages. Then there's a third language. Okay, but I have to say, before finishing the R Tidyverse, it's very controversial. Because the positive side of it is that it's a much easier to use and much more powerful version of R. But the negative side is that it's a completely unofficial version. Because Python has, you can say, a committee that monitors the changes, approves what changes are, so that everyone who uses Python uses it consistently. And R also has this R core team that monitors what changes can be made. And the Tidyverse did not go through that process at all. They just added extensions. So that it's completely compatible with standard R, but if you don't use Tidyverse code, your code might not work so smoothly with Tidyverse. It's kind of as an unofficial way of changing R, and so a lot of people don't like that and refuse to use it, but it's gaining popularity. So, okay. And I use the Tidyverse, so that's the flavor of R that I work with. And DataCamp teaches standard R, but it emphasizes Tidyverse R. Then the third language that you're going to learn is SQL, which stands for Structured Query Language. So SQL is a fourth generation language. It's not third generation. It's an interpreted language, and it's for database manipulation. So a third generation language, to recap, just so that you know, all these things I'm presenting now will not be on any tests. So there's nothing you need to memorize or keep up. I know it's a lot. I'm just giving you background. You're not going to be tested on it. It's just like, the only assessment is doing your DataCamp courses in this course. But I think it's helpful to know some background. SQL, okay, a third generation language, the computer programmer tells the computer step by step what to do in order to achieve the results. Like if you want to print out a report, you tell the computer first to draw the lines outside, then get this data from this database, put it in this place. You tell the computer step by step exactly what you want it to do. That's a third generation language. And because of that, you have a lot of control on exactly what the results are. But a fourth generation language, you don't tell the computer how to do what you want. You just tell the computer what you want it to do. And then you let the computer figure out how to get it done for you. It's not artificial intelligence. Because people program how, a compiler, people program how it will interpret your results and give you what it wants. So that's not artificial intelligence. But the point is, as a programmer, you don't worry about how it will solve the problem. You just tell it what you want it to do. So SQL, you tell the computer the data that you want it to pull from a database and give you. And the computer figures out how to get that data, and it shows it to you the way that you ask for it. And it figures out how to do that. So that's, in that sense, it's much easier to work with a fourth generation language because you don't have to figure out the details of how it works. Another popular fourth generation language is HTML, the language of websites. So HTML programmer doesn't tell the computer how to pull up an image and how to draw lines on the web page. It just says, I want a picture here, I want lines here, I want this text, make it bold. You tell the computer what you want it to show on the page, and the computer figures out how to carry it out. That's the idea of a fourth generation language. And SQL is specifically focused on database manipulation. Can't be used for any other purpose. So it is the standard programming language for manipulating relational databases. You'll learn later, especially in your course on big data, that of different kinds of databases. But I'll say 90% of the world's databases, or probably 90 to 95% of the databases in use are relational technology databases, and they all work with SQL. And most companies work 100% with relational databases. So the point being that this is by far the primary language used to manipulate databases. And it was created in the 1970s by IBM, and the latest official version is 2011, but each database management system has its own slightly different flavor. So the popular versions of it are based on the database management systems. The open source ones are MySQL, PostgreSQL, SQLite. DataCamp teaches PostgreSQL, that's the flavor that it teaches. The MySQL is the most popular open source one. Then commercial SQL database management systems, Oracle is the most popular one. The Microsoft SQL Server would be second in popularity. But the SQL you'll learn on DataCamp will work on all of them. It teaches a common base for all of them. But I think DataCamp also has some advanced database courses that teach the specificities of Oracle and Microsoft SQL Server. But if I'm not mistaken, those are premium courses, and they might not be included in our academic program. Okay. But the ones that you'll be assigned for DataCamp will work on any database management system at